Imagine a machine that can actually analyze the structural architecture of your brain, like mapping out the physical decay of your memories years before you ever forget your own name.
Right, which sounds incredible on its own. But then you have to imagine that exact same underlying technology is, well, it's simultaneously navigating your car through downtown traffic during a rainstorm.
Yeah. And silently correlating your grocery purchases with your heart rate to predict your moods.
Exactly. And on top of all that, it's painting a canvas that somehow brings you to tears in a contemporary art museum.
It sounds like, an exaggerated premise for some sci-fi anthology show.
It really does. But looking at our stack of sources for today's deep dive, that's simply a snapshot of a single day in technology.
Yeah.
Specifically, we're looking at a concentrated daily digest of AI news from May 28, 2026.
Welcome to the deep dive, everyone. We're taking what initially looks like this, completely random assortment of tech updates across wildly different sectors, and we're going to unpack the central thread connecting all of them.
Because when you pull back and view these four distinct breakthroughs together, jumping from medicine to urban mobility to personal data and then fine art, they paint just a staggering picture.
Yeah, a staggering picture of how artificial intelligence is fundamentally reshaping the human experience from the inside out.
Totally.
So our mission today is to uncover that bigger story of AI's expanding integration into really the most intimate parts of our daily lives.
And to do that effectively, we have to look past the individual headlines. We need to examine the underlying mechanisms.
Right.
Because knowledge is most valuable when we understand not just what a technology is doing, but, how it functions and why it forces us to adapt.
Yeah, these breakthroughs in the digest, they aren't happening in silos. They're cascading across disciplines because the core engine, which is superhuman pattern recognition, is universally applicable.
Right. It applies to basically everything.
So let's start with the most intimate application in our stack, which takes us directly into the inner landscape of the human body. We have this groundbreaking development from a leading university unveiling a new AI-driven diagnostic tool.
Yeah, this one is huge.
The goal is detecting the earliest possible signs of Alzheimer's disease. And the source notes it's achieving this with a level of accuracy that was, well, previously thought completely impossible.
And the mechanism driving that accuracy is really what makes this a true paradigm shift. The tool utilizes deep learning algorithms, specifically advanced convolutional neural networks, to analyze brain scans.
Okay, wait, convolutional neural networks. Break that down for us.
Yeah, so basically a highly trained human neurologist is looking for macroscopic visual cues, like visible shrinkage in the hippocampus, for example.
Right.
But human visual processing has hard biological limits. We can only see so much. The neural network it's not looking at the image the way we do.
How does it see it, though?
It's analyzing the scan at a voxel by voxel level in 3 dimensions.
Okay, and a voxel is basically like a 3D pixel, right?
Exactly, yeah, a 3D pixel.
Yeah.
And it's cross-referencing the spatial density of tissues across, millions of data points simultaneously.
Oh, wow. So to put this in perspective for you listening, it's not just a better magnifying glass. Think of it like a master art restorer examining a 500-year-old painting.
Oh, I like that analogy.
Right, because you or I, we look at the canvas and we see a nice portrait. The human expert looks and they see the tension in the brushstrokes.
Right, they see the technique.
Exactly. But this AI is doing the equivalent of, spectral imaging. It's analyzing the chemical degradation of the microscopic pigment molecules to mathematically predict exactly where the canvas is going to tear, a decade before the fabric even begins to fray.
That captures the mechanical advantage perfectly. It is finding statistical anomalies that are simply invisible to the human eye.
Identifying the earliest microvascular changes and all those nonlinear biomarker correlations that precede the actual disease.
Right, and the implications of this are monumental because, with neurodegenerative conditions, time is basically the only currency that matters.
Yeah, time is everything.
If the algorithm can identify the mathematical precursors of the disease years before clinical symptoms emerge, medical professionals can begin interventions to preserve cognitive function much, much earlier.
It completely changes the timeline of treatment.
It really does.
But, that timeline shift creates a massive tension. If the algorithm is doing things that human brains are structurally incapable of doing, seeing the invisible tear before it frays, doesn't this fundamentally box out the human specialist?
It's a very common fear, yeah.
Are we just waiting for the algorithm to diagnose the scan and then automatically print out the prescription? Because the AI sees what humans miss, does this mean the AI is slowly replacing the specialist?
So the source material is very careful to address that exact anxiety. It frames this specifically as a triumph of collaboration.
Collaboration, okay.
Right, because the algorithm is exceptional at the what and the where. It identifies the microscopic pattern anomaly.
Right, it finds the needle in the haystack.
Exactly. But it entirely lacks the capacity for the why and the how. It has no contextual clinical judgment whatsoever.
Ah,
A doctor takes that statistical anomaly and contextualizes it with, the patient's lived reality, their genetic history, their lifestyle, their emotional state. And they use all that to design a holistic intervention.
I see. So the machine isolates the math and the human applies the medicine.
Exactly. The human provides the empathy and the complex decision making. We're basically equipping neurologists with a visionary tool that expands their diagnostic reach.
It's pushing the boundaries by combining these different fields of expertise, not just replacing the humans in the loop,
Right. It allows doctors to act on preventative information they previously had absolutely no way of accessing.
which is amazing. But it brings us to a fascinating pivot point. Like, what happens when we take that exact same core capability, that superhuman algorithmic pattern recognition, and we pull it out of the sterile, temperature-controlled environment of an MRI lab?
Oh, yeah. Dropping it into the real world.
Exactly. Dropping it into the most chaotic environment imaginable.
Okay.
So let's shift our scale from the microscopic landscape of the brain to the physical landscape of the urban jungle.
The transition from analyzing static data to processing dynamic real-time physics, it's
Yeah.
a wild leap.
It is. According to the Digest, major car manufacturers have hit a massive milestone. They are currently testing fully self-driving cars in incredibly complex urban environments, essentially with zero human intervention.
Yeah, and we aren't talking about empty highways out in the desert anymore.
Right, we are talking about navigating rush hour traffic,
Yeah.
unpredictable pedestrians, construction zones, just total chaos.
The technological leap required to move from a static brain scan to a busy city street is immense.
Yeah.
Because, a brain scan sits still.
Obviously, yeah.
But a city street is a living, totally unpredictable ecosystem. The machine learning models in these autonomous fleets, they aren't relying on a single data stream. They're utilizing complex sensor fusion.
Sensor fusion, so that's what combining different types of cameras.
Yeah, combining LiDAR, point clouds, radar, and high-definition optical cameras all at once.
But wait, they can't possibly send all that data back to some cloud server to figure out if, like, a child just chased a ball into the street.
Right.
Because the latency, just the time it takes to transmit the data, would cause a crash.
Exactly. Which is why the breakthrough highlighted in the report relies so heavily on edge computing.
Edge computing, right.
The vehicle itself acts as a rolling supercomputer. It is taking in gigabytes of environmental data every single second and running predictive physics models locally, right there in the car.
Oh, wow. So it's not asking the internet for permission to brake.
Nope. It doesn't just see a pedestrian. It calculates the vector of their movement, the friction of the wet pavement, the trajectory of nearby cyclists. It anticipates an obstacle before it actually materializes.
That is, the downstream effects of getting this right are staggering.
Oh, completely.
The source outlines a total redesign of urban mobility. If autonomous fleets become the norm, it vastly reduces the need for personal car ownership. You don't own a car, you just summon mobility as a service.
Right, which means millions of acres of parking lots can be reclaimed.
Exactly. And it means lower carbon emissions through, optimized routing. And crucially, it offers true independence for people with disabilities who physically cannot drive themselves.
It forces us to entirely rethink the physical infrastructure of our cities. The grid no longer needs to accommodate human reaction times or human error.
Here's the hurdle, though. We've all seen the simulation videos where the math works perfectly and the car smoothly dodges the digital pedestrian.
Yeah, the marketing videos always look great.
Right, but the source explicitly flags regulatory challenges and public acceptance. Like, if the edge computing miscalculates in the real world, who takes the liability? Is it the software developer, the fleet owner?
The legal gray area is massive.
It is. And beyond the legal aspect, the tech might be flawlessly dodging pedestrians. But can it dodge a skeptical public? Is human psychology a bigger roadblock than the actual technology here? We have spent over a century equating car ownership with, personal freedom and control.
Yeah.
Do you really expect the public to just hand over their physical safety to a black box algorithm?
You're hitting on what is arguably the most significant bottleneck mentioned in the report, that psychological friction. The road to fully autonomous driving is getting shorter every day on a technical level,
Right.
but redefining urban mobility requires a massive societal shift. The technology is scaling significantly faster than human trust.
Yeah, the tech is ready, but society is catching up.
Exactly. Think about it. A human driver makes a mistake and causes a tragic accident, and society views it as an unfortunate reality of life.
Right, human error.
But an algorithm makes a single miscalculation with the same result, and it becomes a systemic crisis of faith in the technology. Building public trust requires just an unprecedented level of transparency about how these predictive models make their real-time decisions.
And speaking of transparency, let's build a bridge here. The moment you have autonomous fleets constantly mapping every curb, reading every license plate, and tracking the daily movements of every citizen to optimize those routes, you are suddenly swimming in an ocean of behavioral data.
Yeah, you are.
The sensors keeping you safe on the road are simultaneously mapping your entire life.
The transition from physical safety to digital privacy is completely unavoidable here. The same sensor fusion that prevents a collision is also a real-time surveillance apparatus.
Which brings us to the next section of our digest. It moves into a massive panel from a recent tech conference focused entirely on AI ethics and privacy frameworks.
A very necessary conversation right now.
Totally. Because it isn't just the cars.
Yeah.
AI is integrated into everything. It's processing the audio in our smart home devices. It's analyzing our browsing habits to curate personalized marketing. It's tracking our biometrics through our watches.
And the panel highlighted the core paradox of modern AI, right? The utility of the technology is inextricably tied to the granularity of the personal data it consumes.
You can't have one without the other.
Exactly. If you want the algorithm to detect your Alzheimer's early, and you want the car to route you around traffic flawlessly, you have to feed the models an immense amount of personal data.
Right. And I think about having integrated AI in your daily life. Kind of like having a roommate who is a brilliant, hyper-observant statistician.
Oh, that's a creepy thought.
It is, because this roommate doesn't just notice that you drink coffee. They mathematically correlate your Wi-Fi usage with the inventory of your smart fridge and the heart rate monitor on your smartwatch.
Right, building a full profile.
Yeah, to predict when you're going to have a stressful day.
Yep.
And they pre-order your favorite comfort food before you even know you want it, which is incredibly convenient.
It is.
But at what point does that ultra-helpful personalization cross the line into like a deeply invasive surveillance state? Especially when you realize the roommate is selling those psychological profiles to the highest bidder.
Yeah, the balancing act was the main focus debated at the conference. It's how to decouple the utility of the AI from the exploitation of the user.
Because we can't exactly go back to flip phones, right?
Right, we can't simply shut off the data pipeline without reverting to a technological dark age. It's not about stopping AI. It's about shaping policies that safeguard users' rights without stifling the incredible potential of the tech.
So what do they propose? Because another user agreement I have to blindly click accept on really isn't going to fix this.
No, definitely not. The experts focused on architectural changes, not just policy tweaks, specifically frameworks like federated learning and differential privacy.
Federated learning.
Yeah. So instead of your smart home or your autonomous car sending all your raw personal data back to a centralized corporate server to train the main algorithm, the model learns locally on your device.
Okay, kind of like the edge computing on the cars.
Exactly. Your specific device figures out the pattern, updates its own miniature model locally, and then it only sends the abstracted mathematical lesson back to the cloud, not the raw data.
Oh, I get it. So the roommate learns how to be helpful, but they burn the actual notes they took on my private life.
Essentially, yeah. The privacy protections get baked directly into the mathematical architecture of the system.
Rather than relying on a fragile promise in a terms of service document.
Precisely. It's a robust framework designed to safeguard fundamental rights while allowing the AI to continually innovate. The goal is ensuring the technology serves the user, rather than the user serving as just, raw data fodder for the model.
That makes so much sense. But, if these models are getting so advanced at mapping our physical environments, analyzing our private behavioral patterns, and mathematically predicting our daily needs, it feels inevitable that they would eventually attempt to parse our emotional landscape.
Yeah.
Which brings us to the final and maybe most surreal update in our stack. What happens when AI begins mimicking the most deeply personal and uniquely human trait we have? Creativity.
Right. Moving from the optimization of human life to the emulation of human expression. It's a huge philosophical jump.
It really is. Our final source takes us to a contemporary art museum, hosting a new exhibit of entirely AI-generated art. The digest explains that these aren't just like novelty parlor tricks anymore.
Yeah, they're highly sophisticated.
Right. These pieces are created by algorithms, yet each features a completely unique aesthetic style, exploring the boundaries of machine creativity.
And it fundamentally disrupts our historical understanding of what actually constitutes art. I mean, for millennia, artistic expression has been the exclusive domain of human consciousness.
Yeah, it's how we communicate lived experience, trauma, joy, all of it.
Exactly. So when an algorithm which has no consciousness, no heartbeat, and no lived experience generates a piece of art that evokes a genuine, visceral, emotional response from a human observer, it forces a radical reevaluation of creativity itself. Can a machine truly be an artist? Or is it merely a tool in the hands of a human creator?
Well, I have to challenge the premise of the exhibit here. Like, when we stand in that museum and feel moved by a painting, if an algorithm generates a piece, whose unique style are we actually looking at?
That's the big question.
Because underneath the aesthetic, it's just code. Are we really praising the machine's soul, or are we just admiring the sheer brilliance of the human who engineered the model and typed in a clever prompt? Isn't the AI just an unimaginably fast, highly complex paintbrush?
It's a fair question, but if we look closely at the mechanics of generative AI, particularly architectures like generative adversarial networks or GANs, the paintbrush analogy kind of breaks down.
Why is that?
Because a paintbrush does exactly and only what the human hand dictates, but a GAN operates through a dual network system. You have a generator creating the image from static noise and a discriminator critiquing it against billions of parameters of human aesthetics.
Oh, so the system is essentially arguing with itself to reach the final product.
Yes. The human provides the initial parameter, the prompt, but the machine is exploring a vast mathematical latent space on its own.
So it's making its own choices along the way.
Millions of compositional micro-decisions, defining geometry, blending color palettes, structuring light and shadow, things that the human creator did not explicitly dictate and in many cases could not even conceptualize. The model injects a level of generative synthesis and unpredictability that goes far beyond simply executing a command.
Wow. So it is synthesizing a unique style that didn't actually exist in its training data.
Right. Which is why the debate over authorship, highlighted by the exhibit, is so intense. This really blurs the lines between human and machine. Whether we classify the machine as an independent creator or, like, a revolutionary co-pilot, we're witnessing the birth of an entirely new medium.
It doesn't invalidate traditional human art, though.
No, not at all. Instead, it forces us to define what we actually value when we look at a canvas. Is it the final aesthetic resonance? Or is it the human struggle required to produce it? The fact that a mathematical algorithm can now actively participate in that philosophical conversation is just a profound milestone.
It's wild. Let's take a breath and just look at the journey we've just taken through this single daily digest for you listening.
It's a lot to process.
It is. In one single day of news, May 28, 2026, we have seen artificial intelligence utilize microscopic voxel analysis to map the hidden precursors of disease in our brains.
Right.
We have seen it utilize edge computing and sensor fusion to seamlessly navigate the chaotic, unpredictable streets of our cities. We've seen it force us to draw new ethical boundaries around our personal lives, creating frameworks like federated learning to protect our digital privacy.
Yeah.
And finally, we've seen it challenge our fundamental definition of art by mastering the latent space of human aesthetics.
When you synthesize all these sources, the bigger picture becomes remarkably clear. These aren't just isolated tech updates.
Yeah.
They are distinct manifestations of the exact same underlying shift. Humanity's increasing reliance on systems that can process reality at a scale and speed that completely eclipses our biological limitations.
It is totally staggering to view the landscape from that altitude. But before we wrap up today, I want to leave you, our listener, with a final thought to mull over or explore on your own. Something that builds on the sources, but kind of bridges the biological breakthroughs of the healthcare segment with the creative disruptions of the art exhibit.
Oh, I like where this is going. Fusing the mapping of the brain with the generation of emotion.
Exactly. Think about this. We know AI can now perfectly map the hidden microscopic architecture of your specific neural pathways, right?
Huh?
And we know it can utilize generative models to create entirely new, unique pieces of art.
Mm.
So how long until an algorithm can bypass the human artist and the physical canvas altogether?
Wow.
How long until a model reads the real-time biometric data of your brain and generates a masterpiece mathematically engineered to trigger a precise, calculated cascade of dopamine and serotonin directly in your mind?
That is intense.
In that future, when you are brought to tears by an experience generated exclusively for your neurochemistry, who is actually holding the paintbrush? Is it the machine or your own biology?
That is a profound question for a frontier that is arriving much, much faster than we think.
Thank you so much for joining us on this deep dive. Keep questioning the algorithms around you, keep looking past the headlines, and we'll see you next time.